So what actually happens to your entire global data environment when just one single low-level credential gets compromised? Well, if we look at the public postmortem reports of recent headline-making cyber incidents, the lesson learned is pretty brutal. A single vulnerable workstation can literally escalate into a full-scale organizational catastrophe in a matter of minutes. The idea of traditional network perimeter safety? Yeah, that's entirely gone. Today, we absolutely have to assume the breach has already happened.
Welcome to The Explainer. I'm putting on my senior security architect hat for you today, and we're going to extract some really critical lessons from these public cloud vulnerabilities. For this short, punchy session, we're focusing entirely on one extremely powerful architectural feature that improves cloud security: isolating your workloads using Azure Private Link and Zero Trust micro-segmentation. Ultimately, our goal here is all about containing that blast radius.
Okay, let's quickly run through our agenda. Number 1. The public perimeter erosion. 2. Azure Private Link isolation. 3. Overriding public DNS settings. 4. Centralizing private DNS zones. And 5. Automating Zero Trust governance. Let's dive right in.
Section 1. The public perimeter erosion. Take a look at the stark difference here between legacy and modern network designs. With a traditional, flat network topology, an attacker who manages to breach the firewall, say, through a simple phishing attack, is now sitting inside an implicit trust zone. It's like an open highway that can easily move laterally or east-west, pivoting straight to your high-value databases. But with micro-segmentation, we're dividing the network into isolated zones. We create these micro-perimeters around specific services, which dramatically limits their movement and contains that blast radius.
It's a total shift in philosophy, really. Legacy implied trust relies on broad access. Think of traditional VPNs, where one login grants you this wide-reaching network access, leaving your public endpoints vulnerable to internet-wide scanning. On the flip side, verified trust demands that every single request is explicitly verified. Network location just doesn't matter anymore. We're moving away from brittle IP addresses to dynamic, identity-centric policies with a strict deny-all baseline.
Moving on to Section 2, Azure Private Link isolation.
Let's break down the mechanical advantage of this. By default, a platform-as-a-service resource, like an Azure SQL database, has a public endpoint. Azure Private Link fundamentally changes the game here. It maps that service to a private IP address right within your dedicated virtual network. So now, traffic travels exclusively across the Microsoft network backbone, bypassing the public internet entirely. Once you disable public access at the service firewall, your sensitive data basically becomes invisible to public scanning tools. Look, if you take just one thing away from this entire architecture, let it be this: identity is the new perimeter. You must verify every request explicitly. Shifting to this dynamic, identity-centric isolation means that even if a threat actor somehow finds a network path, they are stopped dead in their tracks if they don't have the explicit, context-aware authorization required to proceed.
Section 3. Overriding public DNS settings.
Now, to understand why DNS is the absolute linchpin here, let's trace the required traffic flow. Step 1, your application requests the fully qualified domain name of your service. Step 2, because you've configured things correctly, that query hits your private DNS zone, not the public internet. Step 3, DNS successfully returns the internal private endpoint IP. And Step 4, your traffic transits securely across the Microsoft backbone.
Actually, setting this up requires some specific engineering knowledge, and surprisingly, this is exactly where a lot of enterprise deployments fail. See, Azure creates a canonical name on the public DNS that redirects to a private domain. You absolutely must override this to create service-specific private DNS zones. For example, for Azure Storage Blobs, your private DNS zone has to be named exactly privatelink.blob.core.windows.net. For SQL, it's privatelink.database.windows.net. Using these exact naming conventions is crucial because it ensures seamless resolution without breaking your existing application URLs.
I really want to emphasize the severity of this risk. Without proper DNS configuration, clients will continue resolving the public IP address and bypass the private link entirely. If your application resolves the public IP and you've properly secured the resource by disabling public network access, well, your app breaks. But if you forgot and left that firewall open, well, you've completely nullified your entire Zero Trust architecture.
All right, Section 4, Centralizing Private DNS Zones.
So as an architect scaling this globally, you're faced with a major choice.
Regional private DNS might seem intuitive at first. Keep the zones local. But because Azure Private DNS zones lack built-in replication, you end up in this administrative nightmare of manual scripting just to keep your regions synchronized. On the other hand, global private DNS uses a single, centralized zone. It's highly consistent and makes automation infinitely easier. For enterprise-scale environments, going global is definitely the clear winner.
To actually build out that global hybrid architecture, you deploy an Azure DNS private resolver in each region. Then you set up inbound endpoints. This part is vital for your on-premises data centers because they use conditional forwarding to point to these endpoints, which allows your on-prem servers to smoothly resolve Azure internal names. You're basically creating a single central hub for DNS routing, which ensures that your private IPs resolve consistently all over the world.
Finally, Section 5, Automating Zero Trust Governance.
Let's map out the policy enforcement point, or the PEP. This bridges your control plane and data plane. When a user or a system tries to access an enterprise resource, the PEP acts as the absolute gatekeeper. It communicates with the policy administrator to validate that the communication is explicitly authorized based on your micro-segmentation rules. Literally no data flows until the PEP says so. This right here is what makes zero trust a reality, not just some marketing buzzword. So how do we enforce this at scale so developers don't have to configure it manually? We use a brilliant Azure policy effect called deploy if not exists. Manual DNS management is just begging for human error. With this policy effect, the exact moment a developer provisions a new private endpoint, Azure automatically registers it in your central DNS zone. And even better, when the resource is deleted, the record gets removed. That prevents those stale, dangling DNS entries that attackers absolutely love to exploit.
Now, obviously, you can't just flip a switch on this overnight without breaking your active pipelines. So here is your safe governance playbook. Phase 1, audit. Deploy policies to discover exactly what's currently non-compliant. Phase 2, remediate. Add those private endpoints to your existing assets. Phase 3, network configuration. Explicitly disable public network access on those resources. And Phase 4, enforcement. That's where you switch your policies to a strict deny-all baseline.
That final enforcement phase? That is the ultimate business value of automated governance right there. Transitioning to deny mode transforms your security recommendations into hard, unbreakable requirements. If a developer tries to deploy a database with a public endpoint, Azure policy just blocks it right at deployment time. You eliminate the risk of accidental internet exposure right at the source, giving you a truly secure by default posture.
All right, we'll leave it there for today. I want you to take a hard look at your own architecture and ask yourself a tough question. Are your inherently trusted internal networks actually your biggest vulnerability? By assuming breach and anchoring your micro-segmentation with Azure Private Link, you finally take back control of your blast radius. Thank you so much for joining me on this explainer, and I highly encourage you to go audit your flat architectures today.